We're going to go ahead and start section 4.2, which is a continuation of what we did in 4.1. So 4.1, remember we introduced what the sine and cosine curves look like, right? And we also talked about if we multiply outside the function, that affects our amplitude, right? Our little number a that's being multiplied out here. So if we want to find our amplitude, all we have to do is consider the absolute value of a, right? If we take the positive value of a, that gives us our amplitude. And if a happens to be negative, remember we talked about how that creates a reflection of the x-axis. I'm going to go ahead and say this means we reflect about the x-axis, okay? We also talked about how to find the period, right? And the way that we find the period is we take 2 pi, which is the normal cycle length for both cosine and sine, right? And we divide it by the absolute value of b. So if you remember, b is whatever is being multiplied to the x inside the function, okay? So this one affects the period. Okay, so if nothing is being multiplied on the x, we can assume our period is going to be 2 pi for sine and cosine, right? But if there is a number in front of that x that is being multiplied on it, then we know that our period is going to have to be adjusted. Okay, so this is how we find our period. So the new thing that we're going to add on with section 4.2 is we're going to start looking at what happens when we add and subtract inside and outside the function. So notice with both a and b, we were multiplying. A was being multiplied times the sine or cosine function, right? And b was being multiplied inside the sine or cosine function. So what we're looking at now is addition and subtraction. So we have this addition, or it could be a subtraction if c is negative, okay? And this is considered outside the function. And remember how we talked about things that happen outside the function happen to the y, things that happen inside the function happen to the x. So if we are adding or subtracting outside the function, what that's going to do is that is going to give us a vertical shift. Okay, a vertical shift, which means we're going up or down. Okay, up or down. Okay, when we add or subtract inside the function, okay, notice my D here is inside the function. That's what we're going to call a phase shift. Now, if you took college algebra with me and you went through the whole HSRV transforming of functions, right, that I grilled into your head, a phase shift is the same thing as a horizontal shift. Oops, shift, not shaft. Okay, and all that means is that we're moving left or right. Okay, left or right. All right, now you will notice here we have the b factored out. Okay, the reason we have this b factored out is because we don't want to have to worry so much about HSRV order. So if there is something being multiplied on the inside, we want to make sure that we first factor that out. We only have to worry about this if there is a b value, okay? So if there is a b value here, what we want to do is we want to factor it out first. So it may look something like, here I'm just going to put a little star, so a little side note. If we have something like y is equal to c plus the sine of bx minus bd, okay? If there's any type of thing being multiplied on the x, okay, so if this is anything other than just a plain x, if there is a number in front of that x, then what we have to do is we need to factor out b first, okay? So just within these little brackets, I'm going to factor the b out. So notice then it will look the way we have it written over here. We'll have the b and then whatever's left in parentheses from each of these terms. That way we can easily see what our b value is, so we can adjust our period, and we'll be able to see what the x is either adding or subtracting, so that we'll be able to figure out our phase shift. Okay, so just to quickly kind of like refresh, I know this is just kind of like a whole lot of letters. So let's just look at like a good old-fashioned college algebra example. Okay, so recall, if we are dealing with something like y equals x squared, okay, that just makes a general basic parabola through the origin, right? So if we wanted to graph something like y is equal to x minus 1 squared plus 2, okay, I know I'm starting with this general shape, just like we're going to start with a sine or a cosine shape, right? And then I have to figure out what transformations have been done. So the easiest way to identify the transformations is to make sure we know if they're happening inside or outside the function, right? So the 2 is obviously happening outside the function. So outside the function, if we add 2, that's like adding 2 to the y's. So this is going to give me a vertical shift up 2, right? And I can just take my y's and add 2 to them, right? If it happens inside the function, like this minus 1, that's either going to affect my period or a phase shift. So here notice I'm not multiplying anything on the x, so that's not affecting the period. I'm looking at subtracting. Now, if I subtract on the inside, that is going to affect the x, so we know it's going to be a phase shift. But remember, our x's are actually backwards from what we think. I don't know if y'all remember going through transformations last time. When we see a subtraction on the inside, this actually moves it to the right 1. Okay. If it had been an addition, we would have moved to the left. So x's are kind of on crack. Whatever happens on that inside, it's opposite from what we would think. Okay. So then, I'm not going to go through the whole process, but I just want to show what we do is basically we were moving right 1 and up 2. So if we started with a parabola that looks something like this, right, with the origin as our reference point, we're basically going to move to the right 1 and up 2. So right 1, up 2, and now this is going to be our reference point. So you can see our parabola move to the right and up. Okay, so this was just a little recall. I'm not going to quiz you or ask you on an exam to do any type of function other than a trig function, but I just kind of wanted to bring that back for those of you who have taken college algebra. Hopefully that kind of helps you remember these shifts we've gone over. Okay, all right, so let's go ahead and work on doing some examples. See if we remember what we learned from 4.1. Okay, so here on page 2, the first thing I notice is that the sine function has stuff inside of it, right? Something other than just an x, which means that we're going to have to find the interval, right? It may not go straight from 0 to 2 pi, so we have to adjust our x's, okay? Notice there's nothing being multiplied in front of our sine, right? Or in other words, our a value is 1. So our amplitude should not have changed, and our normal amplitude from our vertical center up to our maximum or our vertical center down to our minimum is 1. Okay. Then I'm going to look for the period value. Notice there's nothing being multiplied in front of that x. So if there's nothing being multiplied in front of the x, we can assume our b value is 1. Okay? And remember, we find our period by doing 2 pi and dividing that by the absolute value of b, right? So if b is 1, we just have 2 pi divided by the absolute value of 1, which is just 2 pi divided by 1, which is then just 2 pi, right? So we know our amplitude is 1, we know our period is 2 pi, but we need to figure out what our starting x value is and our ending x value so that we can come up with those 5 points to get our nice sine curve. Okay, so I want to go ahead and figure out my interval. Okay, so I'm going to take whatever is inside here. Okay, and remember, I want whatever is inside here to be between 0 and 2 pi. So I'm going to say 0 is less than or equal to x plus 3 pi over 4 is less than or equal to 2 pi. Okay, so the first thing I want to do is find that interval so I can find my 5 points. All right, so I need to get x by itself. To get x by itself, I need to get rid of this addition of 3 pi over 4. So I'm just going to subtract 3 pi over 4. But if I do it in the middle, I have to do it on the outside areas also. Right? So that gives me negative 3 pi over 4 is less than or equal to x is less than or equal to. Now, in order to combine these, I'm going to need a common denominator. So I'm going to stop just for a second and kind of go over here to the side to get a common denominator. Okay. Need common denominator. Okay. So I'm going to take 2 pi and I'm subtracting 3 pi over 4, right? Now 2 pi can be written as 2 pi over 1. So if I want to come up with a common denominator for 4 and 1, it would be 4, which means I need to multiply this first one on top and bottom by 4. So that can be written as 8 pi over 4 minus 3 pi over 4, right? And now that they have the same denominator, I can go ahead and add those together. Or sorry, subtract those. 8 pi over 4 minus 3 pi over 4 leaves me with 5 pi over 4. Okay? Alright, so now I know where my points, my x reference points start and stop so that I get those nice quadrantal sine values, right? So that means that my first x value that I'm going to be using for this one is negative 3 pi over 4. And my last value is going to be 5 pi over 4. Now these are not, I don't know, really nice, pretty ones that we could maybe just like easily figure out, okay, what should my next point be? What should my next point be? What should my next point be? So what I'm going to do is I'm going to figure out what the center point should be. Okay, so I'm just going to say find center point. So if I want to find the center point, that means it's the absolute middle between negative 3 pi over 4 and positive 5 pi over 4. And I can find the absolute middle by just averaging these two values. Okay, so I'm going to say find center point. I'm going to average. So I'm going to do negative 3 pi over 4. Remember, to average, we add them together and divide by how many there are. So I'm averaging two things. So I'm going to add negative 3 pi over 4 to 5 pi over 4, and then I'm going to divide that by 2. So luckily they already have the same denominator, so when I do negative 3 pi plus 5 pi, I get 2 pi over 4 divided by 2. And then I'm going to go ahead and reduce that, because 2 over 4, that just reduces to pi over 2 divided by 2, right? And remember, when we're dividing, when we have a complex fraction, right, that just represents division. So I'm going to write this as 2 over 1 so that I can flip and multiply. So this is the same as pi over 2 times 1/2, right, when I flip and do the reciprocal of the bottom. So that gives us pi over 4. So this is my center point. Okay. Alright, so let's go ahead and put pi over 4. So I had to do a little extra work to kind of figure out our points here. But now it should be easier to see what our center points, or sorry, to see what our other points should be, right? This is 1 pi over 4. This is 5 pi's over 4. So if I start at 1 and 5 and I come in, that puts me at 2 and 4, right? And then my next center one would be 3 pi over 4. Okay, 3 pi over 4. Same thing here. This is 1 pi over 4. This is negative 3 pi over 4. I can count by pi's over 4 until I get to that center value. Now, if that's hard for you to kind of visualize in your head, I'm going to go ahead and scoot this up and I'll show you on the graph. Okay, so I'm going to go ahead and just count by pi's over 4. So here's 1 pi over 4. And then I have 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, 5 pi over 4. And that's the furthest, right? Because this is my last point. I'm going to make the points I'm using bold. Okay. I found that this was my center point. And then I'm going to keep going the opposite direction. So then I have 0. Then I have negative pi over 4. Negative 2 pi over 4. Negative 3 pi over 4. And that's my first point. So that's as far back as I have to go. So what I've done is I've put my first point, which is negative 3 pi over here. I've got my last point, which is 5 pi over 4. And then remember, we average these to be able to find that center point, right? So then to find these other 2 points, remember these other 2 points I need are going to be in the exact center of each of the points there in between. So what I was saying a minute ago is if I start at 1 pi over 4 and 5 pi over 4 and I move in 1, that puts me at 2 pi over 4 and 4 pi over 4. And if I move in one more time, that puts me at 3 pi over 4. So that's how I got this point. Now let's figure out what point is between my center point and my first point. So if I go in by a pi over 4 on the right side, that's going to put me at 0. If I go in by a pi over 4 on the left, that puts me at negative 2 pi over 4. And then I come in one more pi over 4 and I land at negative pi over 4. Okay, so it's coming up with those values so that we have the 5 points that we need for our graph. Okay. All right. So now we know that our amplitude, what our amplitude should be. We know our period is 2 pi. So now all we have to do is put in our quadrantal values for a sine function, right? Because we've already adjusted our x's so they come out to those nice quadrantal. So remember sine, we started out with no sin in the world, right? 0. And then it quickly increased, so 1. Then we go back down to 0, back down to negative 1, and then back up to 0. Okay. So we're going to go ahead and plug in our values so we can draw a nice pretty line. So at negative 3 pi over 4, we're at 0. At negative pi over 4, we're up at 1. So I'm just going to say this is 1. This is negative 1. At pi over 4, we're back down at 0. 3 pi's over 4, we're down at negative 1. And then we're ending at pi over 4. So remember, once we have our points drawn, we try our best to make our connections look like semicircles. Okay? So there's our one full cycle of the sine curve. Okay? All right, let's fill in anything else that we forgot to fill in. I'm just going to go back up to the top of the page. So we filled in our amplitude. We filled in our period. It asked if we had a reflection. We had no reflection because we didn't have a negative, right, in front of our A. And then translation. Did we have a phase shift? So phase shift is left and right. So you can see we did have a phase shift, right? So let's go look at our graph. Normally, sine starts at 0, right? 0, 0, and starts going up. So if we normally start here and go up, right, then notice our picture did shift. Our starting point shifted back to the left 3 pi's over 4, right? We're no longer starting at 0, 0. We're starting back to the left at negative 3 pi over 4. So I'm going to go ahead and say we did have a phase shift that went left 3 pi over 4. Okay, and then it wants to know if we had a vertical shift, which is what this V represents, and we did not have a vertical shift because we know our absolute vertical center is at 0 and our amplitude is 1, right? And our picture reflects that. We did not move this whole picture like up, or we didn't move the whole picture down. So that part was unaffected. Okay. All right. So let's try another one. I I want y'all to try one, but let me see which one I want y'all to try. I think I'll have y'all try the next one. Let me go ahead and do this one because the points on this one can get a little wonky. All right, so first thing I do is identify my A and my B. I look to see if I have a phase shift, and I look to adjust my X's so that I have those nice quadrantal angles, okay? So what I notice right here is that I do have an A. My A value is 2, right, or -2 really. But when I'm looking for amplitude, remember I take the absolute value of my A. So my amplitude is going to be 2. So that means from my vertical center, I should be going up 2 or down 2, right? Now, the negative, I guess I should really put a negative on that because A is -2. The negative on there tells me that I'm going to have a reflection. So I'm going to go ahead and write that in. Should have a reflection about the x-axis. Okay. And then I want to go ahead and find my period. Now, in order to find my period, I need to know my B value. The B value is what's being multiplied in front of the x. So you can see here there's no number in front of the x, which means that my B is 1. So that means that my period should still be 2 pi. Right? Again, you can go ahead and work this out and do 2 pi over the absolute value of 1 and work it out, which should just give you 2 pi. Right? All right, we are going to end up with a phase shift. Now, some of you may be able to look at this and see where our phase shift is going to be, right? X's are backwards, so if we're subtracting pi's over 3, that should move us to the right pi over 3. But I'm going to wait to write it because I want to make sure that our graph reflects that, okay? And then our vertical shift is when we add or subtract outside the function. Okay, and even though you see this -2, that's not adding or subtracting, that's multiplying. That -2 is our A. Okay, so if we had a vertical shift, there would be an addition or a subtraction in front of that -2. Okay, so I'm going to go ahead and say none. We should not end up with a vertical shift. And we'll double check this once we have our picture. Okay, all right, so let's go ahead and adjust our x's. Since it's not just cosine x in here, we know that something has happened. We know that cosine values we want to fall between 0 and 2 pi. So whatever is inside that cosine function, which in this case is x minus pi over 3, we want that to be between 0 and 2 pi. Okay, so we can find our nice x's that give us those pretty quadrantal values, right? All right, to get x by itself, we need to go ahead and get rid of this pi over 3, which we do by adding. If we add pi over 3 on the inside, we have to add pi over 3 on the outsides. Okay? So we end up with pi over 3 is less than or equal to x is less than or equal to, and again here, if you need to, go off to the side because we are going to need a common denominator in order to add these. Need common denominator. So this is 2 pi, and we're adding pi over 3 to it. Okay, 2 pi we can write as 2 pi over 1. And then you can see our common denominator should be 3. So we're going to multiply this one on top and bottom by 3. So that's going to give us 6 pi over 3 plus pi over 3 is going to be 7 pi over 3. Okay. So here, notice we still have a period length of 2 pi. From pi over 3 to 7 pi over 3, that's a 2 pi distance. But our starting and ending points are not 0 and 2 pi like we were used to, right? This is our ending point, and this is our starting point. So I'm going to go ahead and put pi over 3 is our starting point, and 7 pi over 3 as our ending point. Okay, so I want to go ahead and find that center point, right? Need center point. So just like we did last time, to find this absolute center point, I just take pi over 3 and 7 pi over 3 and I average them. So I'm going to take pi over 3 plus 7 pi over 3 and divide that by 2. So 1 pi over 3 plus 7 pi's over 3 is 8 pi's over 3. And then we're dividing that by 2, which can be written as 2 over 1. So if I flip and do the reciprocal, I get 8 pi's over 3 times 1/2. Right? And then I'm going to go ahead and reduce the 2 and the 8. So this becomes 1, and this becomes 4. So I end up with 4 pi's over 3 as my center point. 4 pi's over 3. Okay. All right. So let's go ahead and count by pi's over 3 and see if we can get our other 2 points. So here's pi over 3, and then we have 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, and 7 pi over 3. Okay, so here's our starting point, pi over 3. I'm going to make that one bold. And then our ending point is 7 pi over 3. So let's see if we can figure out the absolute middle. So if we start here and we come in 1, that puts us at 2 pi and 6 pi. And I come in again, that's 3 pi and 5 pi, right? And so my absolute middle should be 4 pi's over 3. So let's go ahead and put, oh, I already did that. I already found that one. Well, we double checked ourselves and we're correct. Hi-ya! All right. So now we need to find the absolute center of our little points, right? So now notice, if I start here at pi over 3 and 4 pi over 3, and I come in 1, that puts me at 2 pi over 3 and 3 pi over 3, but I need the absolute center. So the absolute center of these points is going to fall right here, right? Whatever that point is going to be the point that I need to write right here. But I don't know what that point is. So I need to find the midpoint between these two, okay? So I'm going to average these two values to see what that center point is, okay? So a little bit of extra work on this one. So I'm going to move down so I can do my work below here. So I'm going to do 2 pi's over 3 plus, and I already counted by 3, so that's nice. I don't have to get a common denominator. 3 pi over 3 divided by 2. So if I add 2 pi and 3 pi, that gives me 5 pi over 3 divided by 2. I'm going to write that as 2 over 1. So that gives me 5 pi over 3 times 1/2 when I do the reciprocal of the bottom. So that gives me 5 pi over 6. So this little point right here is 5 pi over 6. Okay, and then notice we have the same problem on this other side, right? If I try to find the absolute middle between 4 pi over 3 and 7 pi over 3, if I come in a pi over 3 on each side, that puts me at 5 pi and 6 pi, but then I'm still going to need to know that absolute center point to come up with my other point. So while I'm down here, I'm going to go ahead and average these values as well. So 5 pi over 3 plus 6 pi over 3, and then I'm going to divide it by 2. So 5 pi and 6 pi gives me 11 pi over 3, and then I'm dividing that by 2, which again can be written as 2 over 1. And then I'm going to flip and multiply. So 11 pi's over 3 times 1/2 gives me 11 pi over 6. So this point right here is 11 pi over 6. So a little bit of extra work just to find those additional 2 points, but it is very important because on your exams, I will count off if all you have are 5 little tick marks and they're not labeled with the actual x values as radian measures, okay? So let's go ahead and write in those 2 points we just found. This is 5 pi over 6 and 11 pi over 6. And now that we've adjusted, we know these are the nice x values that give us our pretty quadrantal angle values, right? So we're going to go ahead and write in. Remember, cosine is our cough, right? Starts up here, goes down, we cough it up. So we're going to start up at 1, and we go down to 0, and then -1, back up to 0, and then we end up at 1. Okay, so we adjusted. Remember, I'm just kind of going back over this. The whole reason we take what's inside the cosine value and adjust it to be between 0 and 2 pi is to ensure that these points that we come up with are the ones that give us those pretty quadrantal angles. And then once we have those pretty quadrantal angles, then we still have to adjust it for anything being done to our y's. Okay, so now we just have to adjust our pretty y values, because here you can see we're multiplying by a -2. So -2 times 1 makes this a -2. -2 times 0 makes this a 0. -2 times -1 puts us up at 2. -2 times 0 is at 0. -2 times 1 puts us back down at -2. So I'm going to go ahead and plot these y values for our given x's, and then we'll double check our amplitude, our phase shifts, and all that good stuff. Okay. All right. So here's, let's say this is 1. Let's say this is 2. This is 1. This is -2. So we're going to start up here at pi over 3 begins at down at -2. 5 pi over 6 we're at 0. 4 pi over 3 we're going to be up at 2. At 11 pi over 6 we're back down at 0. And 7 pi over 3 we end back at -2. Okay, so let's go ahead and connect our dots as best we can. Remember, trying to create semicircles is the best way to get a good picture. Mine looks a little wonky on this top one. Hopefully yours turned out better. Okay, so we can obviously see that it's a cosine curve. We can see that from the absolute center up to our maximum, or from the absolute center down to our minimum, we do have an amplitude of 2, so our amplitude is correct, right? We know that from pi over 3 to 7 pi over 3, we have a 2 pi phase shift, right? Because if I were to subtract 7 pi over 3 and pi over 3, that would give me 6 pi over 3. And 6 pi over 3 is 2 pi. So we still have a 2 pi distance to get that nice shape, right? The only thing we didn't fill in was our translation of our phase shift, which is how far to the left or right we go. So notice cosine normally starts at 0, 0, up at 1, right? So it normally starts up here. Because we're starting down here, we know there's a reflection, which we already have written in, but we're also still not starting here at 0. Notice our picture has been shifted to the right, pi over 3, right? So up here for our phase shift, I'm going to go ahead and write in, we went to the right, pi over 3. And again, if you remember transformations from college algebra, you could have easily gotten this just from looking at the function, right? X minus pi over 3, because we're subtracting in here, it actually moves it to the right. If that's confusing for you, then go ahead and just work out the whole thing, right? And then when you have your picture, you should easily be able to see that it was a transition to the right. Okay. All right. So I would like for y'all to try the one on page 4. If you get stuck, go ahead and play the video and we'll go through it. Or if you finish the whole thing and are ready to be checked, go ahead and do that. Okay, and we'll see how you did. Okay, so I didn't work the entire problem out, but I worked out enough that hopefully you got through as much as I have written down. If not, it's okay, we'll go through it. So you can see here that your A value is 3 over 2. So if I take the absolute value of that, our amplitude is going to be 3/2 or 1.5, right? Our B value is the number being multiplied on the X. So our B value is 2. So when we look for our period, 2 pi over the absolute value of 2 simplifies to just pi. Okay, so that means that we're going to have a shorter period length, right, in order to make this cosine curve, because it's just going to be a pi distance instead of a 2 pi distance, right? Now, in order to see what our starting and ending point should be, I'm going to take whatever is inside this cosine value, or this cosine function, and I'm going to put it between 0 and 2 pi and work it out. Okay, now all we had to do was add the pi to both sides and then divide the 2 from both sides, and we end up with our starting and ending value. But there is one thing that I do want to point out here, and that's our phase shift. Okay, if you start just listing all these things like your amplitude and your period and your reflection and your translation, remember, your translation you cannot list unless you've factored out your b. So what I'm talking about is you can't look up here and just say, oh, it's subtracting pi, so that's going to be a shift to the right pi. It doesn't work that way, because notice we didn't go to the right pi, we went to the right pi over 2. So when I say you have to factor out the b, if you're just listing your translation, you're not actually going to have to graph the whole thing. You have to make sure you factor that 2 out. So if I factor the 2 out, I think my pen here has died. If you factor the, let's find a color that works. If you factor that 2 out, then notice your first term would be left with x minus, when you factor out the 2, you're dividing it off, right? So this would give you pi over 2. So make sure if you're just glancing at this to figure out your translation that you first factor the 2 off. Now you can see that it's actually going to the right pi over 2, right? Which is confirmed as our starting point. Okay, so I'm going to go ahead and write that we went to the right pi over 2. If you're not able to see that until you've graphed it, that's totally fine. But on the problems where it just has you identify the translations and it doesn't actually have you graph it, because there might be a problem where it just asks you for all this information right here. It just wants to know the amplitude, the period, the reflection, all that. Make sure either that you work it all the way out or that you factor that b off so that you have the correct value here. Okay. All right. And then you can see we're not adding or subtracting outside the function, so that means that there's no vertical shift. Okay. So there's the answer to all the questions that we need to know. Now we can go straight into finding our center point. Okay. So we know it starts at pi over 2. We know it ends at 3 pi's over 2. Well, if it starts at 1 pi over 2 and it ends at 3 pi's over 2, hopefully we would be able to figure out the absolute middle, right? 1 pi over 2, 2 pi over 2, 3 pi over 2, right? If you're not sure, you can always put it on your graph counting by pi's over 2. So here's a pi over 2, and then here's 2 pi over 2, right? Which is just pi. And then we have 3 pi's over 2. So this is our starting point. This is our ending point. And you can see this is the absolute middle. So we also need this point, which is just pi. Now, that only gives us 3 points. Remember, we need 5. So in order to find the intermediate x values, right, we're going to go ahead and have to average these guys, right? Average these two to find this middle point. And then we're going to have to average these two to find this middle point. Okay? All right. So if you've already done that, you can skip ahead in the video. If not, hang with me. When we average these two, I have pi over 2 plus 2 pi over 2 divided by 2. I'm leaving it written like this just because that way they already have a common denominator. That gives me 3 pi over 2, right, on top. And then if I'm dividing by 2, that's the same as multiplying by a half, which gives me 3 pi over 4 as that intermediate one. 3 pi over 4. Then I need to find the midpoint of these two. So I'm going to do 2 pi over 2 plus 3 pi over 2 and divide that by 2. So when I add the top, I'm going to get 5 pi's over 2. And when I divide by 2, it's the same as multiplying by a half. So that's going to give me 5 pi's over 4. 5 pi's over 4. Okay. All right. So now that we have our points, I'm going to go ahead and label them here. 3 pi over 4. 5 pi over 4. All right, so we already adjusted to use these points so that we get those nice cosine quadrantal values. Cosine, remember, cough up something. We start up at 1, go down to 0, then down to -1, back up to 0, and we end up at +1. Then the only thing we have to do is account for what's being done to the y. So here we just need to multiply all of these by 3 halves. 3 halves times 1 is 3 halves. 3 halves times 0 is 0. 3 halves times -1 is -3 halves. 3 halves times 0 is 0. And 3 halves times 1 is 3 halves. Okay, so we can go ahead and plot our points. Let's say this is 1, so maybe this would be 1.5. This is 1, maybe this is 1.5. So we'll say this is 3 halves, this is -3 halves. So at pi over 2, we're up at 3 halves. Then we come down to 0. Then we go down to -3 halves. Back up to 0, and back up to +3 halves. Okay. So once we have all our points on there, remember to connect your dots as much as possible, looking like semicircles, so we get that nice curve. Okay, perfect. And then if you ever want to check to make sure you know the period, you can always take your last point and subtract your first point. So if I did 3 pi over 2 minus pi over 2, I would get 2 pi over 2, which is just pi, which is our period length. Okay. All right. I want to show you one more, just to kind of throw everything that we've gone over at you. So I want to do one more. And on this last one, we're also going to extend it for 2 period lengths. So once we have our picture, then we want to keep going and get 2 cycles on it versus just 1. Okay. So when I start off my problem, the first thing I'm looking for is my A and B values. Okay, so here my A value, because there's a negative in front of it, is -2. Okay, so if I want to know my amplitude, I have to take the absolute value of -2, which is just 2. Okay, so I know my amplitude. Then I look for my B value, which is the number in front of my x. Okay, remember that affects the period. So I'm going to do 2 pi divided by the absolute value of B, okay, which ends up just being 2 pi over 3. So that's my period length, okay. And then I want to know if I have a translation or a phase shift. That's my horizontal shift. Now notice, because I have a B value that's something other than 1, if I want to know how far to the left or right I've gone, I would have to factor that 3 out. So if I factor that 3 out, that's going to leave me with an x. And if I do -pi divided by 3, that leaves me with -pi over 3. Okay, so now I can see that I do in fact have a phase shift or a horizontal translation. Because it's a subtraction, that actually tells me it's going to go to the right pi over 3. Again, if you have a hard time coming up with this from looking at the equation, you can wait until it's graphed, and you'll be able to see, instead of starting at 0, 0, that we're starting at pi over 3. Okay, so there's that bit. And then I want to look and see if I have a vertical shift, right? And notice I do. This tells me that I have a vertical shift because that 4 is not being multiplied, so it's not an A or a B. Since it's a positive 4, that means we're going to vertically shift up 4. Up 4. Okay, so there's all the information that I need. Now we just need to graph it. So to graph it, we're going to adjust our x values so that we get nice, pretty quadrantal sine values. So I'm going to take whatever is inside the sine function and put it between 0 and 2 pi, because that's our normal phase shift. And then we're going to solve it for x, so we know our starting and our ending x reference points, right? So I'm going to go ahead and get rid of the pi first by adding. Add pi to everything. So I have pi is less than or equal to 3x is less than or equal to 3 pi. And then I'm going to divide off my 3. If I divide by 3 in the middle, I have to divide by 3 on the outsides. So I end up with pi over 3 is less than or equal to x is less than or equal to pi. So hopefully you can tell here, to go from pi over 3 to pi, that is a distance, right? A period length of 2 pi over 3, right? Because it's 2/3 of that pi distance. All right, so this is our starting point. This is our ending point. So I'm going to go ahead and write those down here. We're starting at pi over 3 and we're ending at pi. Okay, so let's go ahead and find the center point. Let's find the center. So all I'm going to do is take my starting and my ending point, and I'm going to average them. So pi over 3 plus pi divided by 2. Okay. Now in order to average these, I am going to need a common denominator. So right now this is like pi over 1. My common denominator on top would be 3. So I'm going to go ahead and just multiply this one on top and bottom by 3. So now we can say pi over 3 plus 3 pi over 3 divided by 2. If I add the top, pi over 3 plus 3 pi over 3 gives me 4 pi over 3. And then I'm dividing that by 2, which is the same as multiplying by 1/2. And then I can reduce. This is a 1, this is a 2. So I end up with 2 pi's over 3. Okay, so that's going to be my center point, 2 pi over 3. So far it kind of looks like we can count by pi's maybe, or pi's over 3 rather, sorry. Alright, so let's go ahead and label our graph. We can count by pi's over 3. So here is pi over 3, 2 pi over 3, and then 3 pi over 3, right, which is just pi. So here's our starting point, here's our ending point, and here's our middle point. So that only gives us 3 points. So again, we're going to have to find those intermediate values. Now, intermediate values is going to, well, I'm not going to say that. Never mind. We're not going to say that. Let's just go ahead and find our midpoint. Okay? So if I want to find the midpoint here, I'm going to do pi over 3 plus 2 pi over 3 and divide that by 2. So that's going to give me 3 pi over 3, right, which is just pi. And then I'm going to divide it by 2, which is the same as multiplying by 1/2. So if I cancel my 3's, this just gives me pi over 2. Okay, so that means this little point here is a pi over 2. And then I need to find the midpoint between these two, right? So we're going to do 2 pi over 3 plus 3 pi over 3 and divide it by 2. So that's going to give us 5 pi over 3. And then to divide by 2 is the same as multiply by 1/2. So that gives us 5 pi over 6. So I know that this point right here is 5 pi over 6. Okay, now if I did this really quick, you can always pause the video and go through that a little bit slower. But all I'm doing is averaging the two values to find the center points. All right, so now that I have 5 points, I can go ahead and put my other 2 points up here, which is pi over 2 and 5 pi over 6. Excuse me. Alright. So I picked those specific x values so that I would get the good quadrantal values for sine. So remember, sine starts at 0, there's no sin in the world, and then it goes up. So 0, 1, back down to 0, down to -1, and back up to 0. And then we have to adjust for our y's. Now there's 2 things happening. Notice here, I have the -2 that's attached to my sine, okay? That means I'm multiplying by -2, right? And then I have this 4 out front, which means I'm adding 4. So I have to do both operations to my y values, okay? And we always do it in PEMDAS order, right? We do our multiplication first. So we're going to do -2 times 0 and then add 4, -2 times 1 and then add 4, -2 times 0 and then add 4, -2 times -1 and add 4, and -2 times 0 and then add 4. And then we just work it all out, okay? So on the first one we should get 4. This gives us what? -2, so +2. This should give us 4. This should give us 4. And then our last one, let's see, that gives us 6, right? All right, so we have our new y values. So I'm going to go ahead and I'm just going to count by 2's on here. 2, 4, 6. Okay. Let's go ahead and draw our picture. So at pi over 3, we're up at 4. At pi over 2, we're down at 2. At 2 pi over 3, we're back up at 4. Pi over 5, we're up at 6. And at pi, we're back down at 4. Okay, so we're going to go ahead and draw our curve here. Alright, so there is our sine cycle. So you can see normally sine starts at 0 and then goes up. So we can see we have had a reflection. Did we write that down? I don't remember if we wrote that down or not. Let me look back up here. Nope. Yes. About x-axis. Sorry, I forgot to write that one in. Okay, so we did have a reflection about the x-axis, right? And we know that because we had a negative a value. If you look up at your a value, it was -2. All right, so a couple of things I want to point out. Number one, you can see that the vertical center is here at 4, right? So our amplitude from the vertical center to the top we can tell is 2. Our period length is 2 pi over 3. Now on this problem, if you flip to the back page, it says it wants us to extend it out another period. So I already know that if this is what the wave looks like, I can continue that wave again and make another cycle. But I want to make sure it's accurate and I know the actual x values of the additional 5 points for the next cycle. Okay, so what I want to figure out is what type of length do I have between my points. Because if I know that this length is, say, like pi over 4, then I can just start here and start counting by pi's over 4, right? So to find the distance between pi over 3 and pi over 2, I'm just going to subtract. I'm just going to take pi over 2 and subtract pi over 3. Okay, so I'm just going to write over here distance between tick marks. I'm going to take pi over 2 and subtract pi over 3. Okay, now I need a common denominator, which would be 6. right? So this one I would have to multiply on top and bottom by 3, so that would give me 3 pi over 6. This one I would have to multiply on top and bottom by 2, which would give me 2 pi over 6. So 3 pi over 6 minus 2 pi over 6 is just pi over 6. So that means that I have a pi over 6 distance between here. So to go from here to here, it's pi over 6. To go from here to here, it's pi over 6, pi over 6, pi over 6, blah, 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 right? So I want to go ahead and start at my last point. So my last point here was 3 pi over 3, or just pi, right? I could write pi as any number pi over that number. So since I want to count by pi over 6's, I'm going to think of this point as 6 pi over 6, right? That still just equals pi, right? But I'm writing it with the denominator of the distance value that I'm going to be counting by. So if this is 6 pi's over 6, then my next one would be 7 pi's over 6, and then 8 pi's over 6, and then 9 pi's over 6, and then 10 pi's over 6, right? I need those 4 additional points, because if I'm going to start it where this one ends, that's my first point, and then second, third, fourth, fifth. Okay, and on your exam and on your worksheets, I'm fine with you leaving it like this, where you just count these additional points by pi's over 6's. If you want to, you can reduce these, but you don't have to. Okay, so 8 pi over 6 is the same as 4 pi over 3. 10 pi over 6 is the same thing as 5 pi over 3. But I'm not too worried about you converting these if it's just an extra cycle at the end. Okay, so here, this next cycle just needs to mimic this one. So notice our first point is at 0. Our next point should be down at 2. And our next point should be back up at 0. And then our next point should be up at 6. And then our last point should be back down at 4. I think I said 0 before. I didn't mean to say that. Okay, so you can see here we have continued on a second cycle. Okay, same vertical distance. Okay, so make sure, and we could have gone in the opposite direction as well. Usually, I don't know, it just depends on the problem. Sometimes they'll tell you which direction to go, or if it's multiple choice, you'll see. But basically what I want you to see is that this is one cycle, right, from here to here, and then we're just continuing it on an additional cycle that looks exactly like the first one, and then we want to make sure that we have those points in there. Okay, all right, so that is the end of section 4.2. Again, we don't need the back page here because this is just saying extend it 2 periods, which we did on this last page. So there is a regular MyMathLab assignment for section 4.2 as well as a worksheet. So make sure you get both of those done. If you have any questions, please let me know.